Alrighty, so next concept talk. We're going to talk about the fact that I have my turbine design, which is an in-out approach, which I've discussed previously in my YouTube channel, and I mostly design it in 3 sizes, the smallest of which would effectively be better for a semi truck, with the medium being like fairly large for like a turbo prop hybrid jet engine, because it'll compress a lot of that air, but then the air goes around it, cooling the engine, but also like having that exhaust go into the rear, and then it compresses with the heat and the air, and then it goes to a smaller opening than a bell end housing to improve its thrust characteristics for the given altitudes it's at. But it also has to move the bell end slightly, but it uses a degree of pressure differential to maintain its atmospheric condition, your 1 atmosphere press, for what it's worth. Right, anyways, for the bell end, but I'm going to move off of that. Okay, so I have to talk about that because, like, that turbine runs off of hydrogen, and it uses a very similar style, like our carbon design, to improve its efficiency by making a hydrogen peroxide, and nitrogen peroxides in its given layout, which is a just kind of similar ram air, but the fan and it has a front intake and a rear intake, and those are compressors. But then it has a hub which allows for hydraulic fluid to move through it, and it also has spacing for vacuum insulation alongside of the counter-rotating blades, which are hollow, which allow for it to then have the fuel and air pass into a chamber, which then, as they counter-rotate, they compress, and then they go through, take your fingers here, they'll go through individual spots. Okay, now, if you're talking to someone else that isn't me, alright, and trying to explain this to them, I'd prefer that you use their name, because like I heard Blargy in my head, and it's like my old name in real life, well, not in real life, online, which kind of feels that in real life, that's the reason why I said that, is Blargy Paston. Same thing with Knives Are Fun as my Gmail. And then I told people while I was in the mental health hospital that I was going to change my given name from John Tyler to Blargy. And since I already know that this is my engine, then it's not needed or necessary to tell me. The reason why I say that is because, well, that could be a quantum connection from the future, past, or current heading around, or it could just be a voice from a thought. You never really know. It's kind of hard when there's like a field that can definitely ultimately kind of trap and entangle, given neurons or neuronal firings within the 8 billion plus of us on this planet. It's like it's pretty likely that we would ultimately have a bit of an entanglement there over distance, and there could be transmission of memory or thoughts over distance. So there's that going on. So it's like I'd prefer it if you were not to talk or say something. Plus, there's a reason why that name exists for me. Blargy Paston is a curse word. It's like Friendle. I was in middle school and football, and they would have you do 25 push-ups for each letter of the curse. It took one time for me to have that happen, and Blargy Paston came about. Blargy Paston is my creation in middle school as a fuck you or so on and so forth. So that's why that's there. All right. Now, moving on to the turbine, the blades are connected to the inside. There's a outside and inside and an outside set of blades. So there's an outside set of blades which counter-rotating. How does that work? Well, they're in sections and there's gears, and you're stupid if you didn't know that, because that seems pretty obvious to anyone, because hydraulic fluid and engine coolant still has to be there. So you have bearings as gears that would allow you to counter-rotate and combine it to the main outer axle. But the hub axle is like, oh, so you did listen to my YouTube video that's on YouTube, Seen on Reality. That's kind of what that is. You know what I mean? I put that out there already. But the point is, it's like the hub is hollow and it allows for it to send hydraulic fluid from the rear and the front as it moves around like a torque converter to push fans for the front and the rear. So like there's a bifurcation of the top and rear exhaust, with the intakes along the sides being vacuum insulated, along with the exhaust manifolds vacuum insulated. But the exhaust manifolds goes into the other fan blades, which are, of course, usually on a pack. Like typically you can do 1, 2, 3, you can do like up to however many packs you really want in a blade configuration, but the exhaust will go from the out to the in and inside of the next, counter-rotating and rotating assembly in the rear, behind the first, combustion turbine area. Now, that's a plenum volume, but then that's also the rear is a compressor, and then the front is a compressor, and then you have the ram air that I just talked about. So as a result, it's like, well, that gives me increased efficiency for compression of air, and then like that plenum volume is also trying to compress it up to where the intake, which is a sliding part, which goes up and down. So there's the engine housing that goes around, which is not stators anymore, and they're hollow. And so as they rotate around that, engine housing, then a channel is formed that allows for the air from the inside to pass into the hollow part of the blade, then travels through the hollow gear that allows for that to go into the other counter-rotation part of the blade, fills up the volume as they come closer together, and then there's injectors, which is direct injection, but you can also add in some degree of efficiency by having depending on the compression and heat here, port injection effectively to that little zone, and like that increases its heat, but then it's getting squeezed during that. And so then as that spark is ignited, and then there's the correct channeling and funneling effectively, it goes outward, and then you can dump in more fuel in that area because you have centripetal and centrifugal forces along with as that thing rises and lowers. So like if you don't know, in the engine housing there's a gear that's rotating, okay, but it goes up and it goes down, okay, inside the engine block stator areas that are still going to be hollow and still have fluid go through them. Now, what that does and allows for is a compression of that blade area, but also it moves air through while also allowing for that to act like a valve. So, as that goes into the upward position, it will move another sliding valve, which is attached next to in the stator area for fuel flow. And so we can energize fuel and dump it in as a highly, because it's hydrogen, volatile plasma. And then that allows for that to mix extraordinarily efficiently and ignite in a detonation capacity. Now, as it expands into the upward part of our blades, it's trying to curve itself and do a vortex as it spreads. So the blades are shaped kind of like right-angled triangles, is what I say. They're kind of like that, but they're not. They have to be curved and they have to have the right spacing and everything with the geometry, and the stators in between, which are your fingers as you press them through, that allow for compression, and then like a gap, and then ignition, and then continuation of fuel intake, compression, and flow into the given rest of the area. Okay, which then gives you detonation velocities. Anyways, we're vortexing it, and as the blade comes over, it continues to keep an area there for it to continuously press out and give you torque. As it expands and presses out in that area, it's continuing, because it has to be shaped with curves and everything to do that. Well, that gives you extra, force outward while having a vacuum area for it to blow into. And expends its energy upon so doing that to the blades, and then it will go to the point where the blades have passed far enough, and then the port for the exhaust is now open. They have to be curved the right way, they have to be long enough. You get the picture. The geometries have to be right. But what it means is vortexing increases its efficiency of capture of energy. As such of that going on, okay, which is a long-winded fucking college professor way of saying, so because it's better and more efficient, it means that it's able to handle the hydrogen very well. Then the axle, with the counter rotation in the gear, allows for its own degree of electricity generation. That's its own version of an alternator. It also introduces degrees of force, as it comes out, because it's very pressurized, but then it's also moving, but then it has a sudden release, and it's a smaller nozzle, then it'll widen, and then it'll shrink. You know what I mean? Because that's the balancing of the blade. You have to have it first go a little bit, but then it's sealed to that, and that's engine block for what it is, because there are versions of stators, and it's gaps and so on and so forth. You get the picture on that, I hope. Which if you don't, then it's like, okay, so I have a stator, I have to combine, and then it has to exist within inside, and then I had to, and then you clamp everything together, circles, a circle and a circle and a circle and there's a lot of things like that, effectively. A lot of bolts and shit, which aren't really a lot of bolts. There are more latches. For what it's worth, there's a bolt pattern that is there, but it's on the outside, and because it clamps it together, then that sticks it in with barb kind of style clamp fittings, latches, and so on, that then sticks everything together. It's about being able to conceptualize a 3D space with a 2D, 3D degree of something inside of it that then allows for you to get this. So the hub is the only real, it's kind of like an Archimedes screw with holes through it that allows for lots of fluid pass through, but then it's still pumping. Kind of like toroidal, but they're not. It's an Archimedes screw, but with holes that are elliptical, that are basically just kind of larger than angled. So they're larger on one side and smaller on another, and then they're angled, so that way it improves the efficiency of the screw design and pass through of the fluid flow, which improves its efficiency, volumetric efficiency. Now that goes off into the front, which is going to expand because it's supposed to be very hot, and there's a vacuum insulated area between the center hub and then the outside, which is a 5 diameter intake into the hub, which is that intake hub is 3 inches in diameter. And so then there's the donut ring area that has a version of similar stators, which is casting and then putting the infill of ceramics around it, because it's a bunch of ceramic that's actually electrically conductive ceramic, but not electrically conductive ceramic. A good way to put it is, it has this stuff that it's inside of, it's electrically conductive. Then it plates itself kind of like a negative and positive charge powder coating around the cast aluminum, hypereutectic aluminum, that has a bunch of holes in it. And then that's like a version of casting, as you put like the stuff that's there that you don't want, but then you have to have the right electromagnetic to kind of hold it, and then you effectively just put it in the right water that dissolves the supportive material. So the casting works just fine. The ceramic is very not porous anymore because of the static charge and the powder coating, and then the heating, which is caused by the electromagnetic static charge differences as it layers itself down on it with some good vibrations. Hey, as it's within the spec and heating profile of the aluminum. You get the picture, because that's conductive, and then it's conductive, and then that's not conductive, and the electromagnetics, which is around it, and so eventually you slowly get the whole fucking damn thing built and cast with the right vibrations, which remove the totality of any and all porosity. As a result, I'm better than you. Deal with it. Your concerns were taken care of. Now, listening to this will probably get you angry, so be careful. I get your concerns were already addressed. You just didn't listen to it in the first video, which is why I'm angry. Now, that's why there's a ceramic that's really the real top dog performer here that really improves its outright capacity. Because if you don't know, when you remove the water, then there's no air. It takes the volume up of the air, so it's like it's in a vacuum, but the water went away, and then it's sealed as it's layered over that. So it's vacuum insulated, and then it's insulated with ceramic that's extremely insulative and has no porosity value and has basically no creep, but it has a little bit of give and bend because you can layer it the right way to do that. Now, as a result of that whole concern taken care of, the turbine is remarkably efficient. Wow, it even has incredibly hard surface areas that allow for, with the boundary layer that's there that is reduced by having large amounts of little tiny vacuums, cavitations that are produced, it improves the reduction of friction and fluid flow dynamics, especially with that style of pump screw. Now, same thing kind of with the compressor in the rear. As air is channeled from the sides, it then gets taken from the outside towards the center, and then the ram airs in the front. It's kind of like a scramjet. It goes from a wide parabolic with the things I was talking about in the last, then into a version of this that spins, and then it just goes from the inside outside, and then back towards the inside, and then it gets split along the sides, and then that then gets shoved towards the front, which is around the whole of the hub, which the hub is an entirely different thing than you think. So let me tell you about why you're stupid and you think it won't work. The hub is connected with a clutch gear system as the expansional property of the heated vapor, which is a liquid under pressure, but then I drop the pressure, so it should, with the right heat, then turn into a vapor. It then presses, using the hydraulic fluid vapor pressure, onto the clutch and gear. It then allows for it to slip and then change its gear. At first, it's a supercharger. Then it turns more into a turbo. Then eventually it goes back into a clutch-driven after the gear is hit, and the pressure of the hydraulic fluid going into a vapor spins it faster, which then also then compresses as it goes outwards, which is vacuum, and it's another version of the stupid ceramics that you hate so fucking much, apparently. So it's very low amount of that heat that gets into that compression. And in fact, I run a water jacket around that, especially with inside the outer part of the axle, because the hub is not really an axle. The axle is the in between, where the screw on the outside between the hub is ultimately a, cooled, hollow version of that too. So it's like I have to run coolant through that, which is fine. I don't mind that. Like, I can easily separate that. There's nothing saying I can't do that. I don't need capillaries. They're quite large. You know what I mean? For what it's worth. And they're rotating correctly to make it so I don't have to worry about that. That kind of thing. It's like a reservoir that goes towards the center and then out. So it pulls it out. Then into the engine block, which is then out to in. It goes from in to out, and then it goes from out all the way to the outer edges, and then it gets sucked back in. Some of it's diverted and cooled, which then that goes through the center out to in, cooling the turbine combustion zone area. All right, are we on the same page yet? Have you caught up, you PhDs, to a person that doesn't have PhDs? None at all. And I dropped out of college and I have a GED. Have you caught up yet? Yeah, sure, why not? We caught up, fine. Alright. Maybe you can just watch the other video before you have to get a refresher. This is a subtle way of saying watch the other video before you watch this one. Maybe that'll help you out. Perhaps. I don't know. Anyways, this is for the other audience members that will probably unlikely do that because it's fairly long and they are tedious people that can't have any attention span on anything at all for any length of time. So there's that. The refresher course is basically done, but then I'm refining it by telling you even more about what's going on with this. If you don't know, some of this was not in that video, and it's refined so that way you can understand it a little bit better, because this is my design that I would do to make this work for me. I had the basic concept, rough drafted, and then I've been working on it to further increase its degree of possibility and actually working. Especially with the Ram air intake that I got now, which is effectively better in all aspects than anyone else's by efficiency margins of actual compression. Especially since like a turbine is fine with heat. Baser, come on! Where are you? Where'd he go? Baser. Right, there you are. Come on. Come on. Doing the laundry inside the house. Anyways. You have a house? No, I have an apartment. Oh. Yeah, but my mom has a house and she has like free laundry things, although she has to pay for the electricity and everything. But I don't have any income, so like that makes it so it's free for me. And she doesn't want to pay me money to go to the laundry that's over there. And so as a result, it's like, well, this is now my place to go do laundry. So that's what that is. Anyways, now we're right to the efficiency, blah blah blah. It deals with the heat just fine because ceramic is really, good, and you just need to dope it the right way with the layering to have the spark in the ground. Conductivity, it's fine to be energized into a slight plasma and then turned into a plasma through that, squeezing and pressurization valve setup, essentially, which is the correct amount of gapping and drainage of electricity by using electron flow, by increasing its degree of electricity and then dropping it out. which allows for, yes, that's right, plasmification of the hydrogen. Alright, hearing aids on. Alright, so, as a result of the hydrogen coming in already preheated, and then there's already a degree of deflagration. As it gets injected, it's using the exothermic properties of the air that's already there as it crashes into that, being already relatively statically charged. And a positive to its negative, increasing its exothermic reactivity, improving its detonation characteristics. Which is literally why static ionic wind works. Well, this is a plasma and static ionic wind version that uses exothermic reactivity to improve its efficiency. As a result of this, I gain a massive detonation velocity, but then I have it spread over a very large surface area, and I actually want that because that presses the center with the greater degrees of torque, whereas the outside is using the capturing of the expansion and vortexing exhaust, which increases leveraging and torque. Now, that is a version of its own gears for the rear, as well as it goes from outside to in with the air and a simple seal for its rotation. If you don't know, there's this thing called a transmission, and it's sealed, and it can rotate, and it's pretty good at keeping it sealed for a fairly long time. And then there's differential axles that seal up and are good at keeping their seals for a while. So maybe we do something like that isn't stupid like what you think, where it won't work because it needs to be sealed, and you apparently can't fathom how you could do that. Because somehow, some way, you're smarter than all of the people that came before you that made rotating seals and assembly. Somehow, some way, you figured out that would never work, even though we use it every day, and you're smart. I like fucking around because it's like, if you've kept into this point where like you listen to this long, you probably already know that would work, and this has nothing to do with you. It's just idiots that are in the comments that think they know everything, and really realistically are obvious fucking trolls at that point, because only engineers would probably be like, yeah, no, that's really simple, actually, we should do that. You know what I mean? Like, there's not really anything stopping us from doing that. What stops us? And it's like, well, you have to be pretty intelligent to put it together that way, for what it's worth. For what it's worth, and there's a lot of decent, like, cost overhead here. You know, like look at my RAM air intake. Like, we have a version of that. And all it's using is cooling. It's using cooling. And bifurcation, meaning compression, and a ram air. You know, it's using a bunch of methods to really improve its efficiency of its design alongside of the rotating part of its assembly. And then it's like, well, okay, so how do you get the energy out? Is it the stator area? It's like, no, that one's the rough part. See, the rear compressor is actually a donut. So it goes from out to in, but at the same time, it's like, what it means is like it's connected to the axle and then the internal hub axle. And it has to be separated with the right bearings and vacuum, and it produces its own version of, capture of that energy into that axle, meaning because it's pressing in the front, it'll eventually connect back to the axle and then send that energy back into the system to be able to improve its capture of work energy for the given design. that's why that works. It's not just those torque converter style turbines. It's also the total rotation, not just from combustion, all right, and not just from, you know, it's trying to capture everything it can, which it can do that. If you don't know, it can do that. That's a clutch-driven system. We use them for our transmission. If you don't know how that can happen, well, there you go. You have a clutch for your transmission, and you're stupid because you asked, which isn't true. You're not. But if you literally were about to write in the comments, that won't work because I don't, yeah. And it's like, no, it will absolutely work. There's nothing saying that won't work. And I even stated that before, which meant you were not paying attention. Just to let you know. That's how I view that. That's how I'm always going to view that. That's like, you're really fucking not paying attention. You need to fucking listen, and you definitely need to shut the hell up before you make a mistake and comment something that's going to make you look stupid. There's nothing wrong with looking stupid, but then that's just not even in the ballpark of trying to figure out. You're just trying to shit on someone's design that doesn't actually in any way have any bearing or weight, because, oh, it turns out he did address that. And then you'd think away, actually, I was just trying to pretend to be stupid. And it's like, no, you weren't. No, you weren't. Get out of here. Fucking jackals in the freaking comments every time. That's what my mind goes to. Anyways, moving on to that gives back some of its energy. And that's also one of the reasons why it's specified to a given PSI value, because the valve opening and closing and its lift basically as it turns, that also adds compression. Same thing with the compressor coming in, and then the screw from the hub to the outer part of the other shroud, effectively, which is a double hub, I suppose, in a way. That one's a version of through holes, all right, from the front and rear, so that way the oscillations are able to be sent forward and backwards. But that also means, because they're hollow, but they don't really need to be fully hollow. They just need to be, rigid and allow for those holes to be there to improve fluid efficiency. Instead of having to go around a screw, they can go through that and also around and combine at the spot where they're intaking. They also need to be very differently angled, so like they're rather wavy for what they are, with holes that actually act as supporting structures to the waviness, that also act as their own version of compressors. So as they go through one area, another area is going to bifurcate that and then add that to it, thus helping compress as it rotates from front and rear, depending on the direction. Because you can have multiple of these blades go off, or you can do what I usually do, because one of them is really, really, really extraordinarily powerful. Like, it's detonation and it's a bunch of little you know what I mean? Like, and then that goes off and then gets captured, and then I can just send that as the exhaust into the middle and then the rear, 2 and 3 respectively, and capture some of that heat and pressure energy by using the exhaust manifold, and then having that curve back in to its intake. Instead of having intake from the axle area, it's just for the front, which then turns that into, well, I'll take the intake from the exhaust and I'll have a little bit of intake from the middle that is just going to add in air. Well, because it's fairly highly charged, if you can do it right, you can make that electron flow, meaning rip out electrons or increase the electrons. I usually increase electrons. Increasing electrons means it'll crash back out. Okay, as I push air in, then instead of having it be like a ground, I remove electrons. That's the electron flow part. But I take a little bit of work energy to do that. which is fine because I'm going to capture it, truthfully. Just, fine. For what it's worth, and it's a different type of design because it's like there's heat and there's pressure oscillations. So it's like exhaust doesn't all come from one side and one side. You know what I mean? It's one, because it's like that's how the blades work. There's multiple blades, multiple angles, and so it's like one. But you have, let's say, it was only 9 and 3, and we made 9 and 3 pretty large. So it's like a little closer to 2, and a little closer to 4, and so on, right? But then all of that top can have multiple different areas where it can exhaust. And so it's always being interacted with as it intakes and effectively continuously compresses, sucks in air, but also cannot always continuously because we have the valve and the gear, okay? Right, which is separate to the valve and gear, or not valve, but gear that it's attached to the axle housing, fan shroud thing, like the inner, instead of the hub, then it's that, and then you have the blades outside of it, right? So it's like that has to be attached, that has to be its own bearing, that has to put its energy into that, right? So that's why it's like, well, that one's simple. I can do that. That's just a round piece, and then you stick that together, and then you clamp some of the other ones on, depending on how you want to do it. Personally, I was more of a screw clamp, and then like bolt kind of thing. So that way it like latches on, and then just in case the bolts are the right, gram weight. Like you want it to go really, really fast. But it's going to be contained within fluid and everything, and so you have to make sure to cover it, all that stuff. But what it means is that it's very low drag for the fluid that is there, and they're able to be phaser. They're able to be very balanced and quite strong structurally, with multiple connection points instead of just one bolt. So as a result, it's also able to use that valving in such a way that it can also have it flow through during its rush, meaning like after it first started using the compression and combustion cycle. As it's going down, I can have it go open, reopen, re-energize, and restart the process. It's going to be a different one because instead of an ultra high compression, we use what is effectively an ionicking style, meaning very grounding and very high electron, version that's going to be run that way, okay? And so it's not going to compress it, but it doesn't necessarily matter as much in my mind. So it's like I gain the efficiency during that moment, but then if I want to gain really high amounts of power, I can then have that still intake, but it's going to be a different version. Like it's like the exhaust on a valve system. Now the exhaust is an intake, and so before it was like, well, it's always going to be just closed. Well, now it's like, well, now it's open during the downward cycle, and so I have a upward high compression and then downward much higher flow rate. Yeah, for that design. But I use more exothermic reactivity to keep the power there versus a higher degree of compression. But along the exhaust area and towards the intake, I use the same kind of design by using charge fields and the right materials to allow for more hydrogen and nitrogen peroxides to form. And I then start the process of using pressure oscillations and reflectivity material, meaning reflectivity material areas inside the next blade side to then heat up dramatically and then break down some of those peroxides while introducing some air as it compresses. Okay, so reflectivity, and that is just in constructive and destructive interference with the pressure oscillations being concentrated in specific ways in that chamber, which really just means it's really concentrating it to go through the compression stators on the blades, you know, while heating it up and helping break down some of those compounds initially. Okay, and I'm adding more air in, which tends to be, which is more negative, it's more plasma, kind of. It depends. It's like, do you want that extra, heat energy and everything? And say, well, it's hydrogen for me. And so the answer was no. But for ultra high performance, I was willing to do it. Because it's like, well, that's just another version of using exhaust turned into another exothermic reactivity version, which gives me more energy than I initially put in, because I don't need to plasmify the hydrogen, which the hydrogen can be used sparingly, especially since, and I'll get to it on how that goes on, but the exhaust gets rerouted back into the middle using its own version of pressurized oscillations from the final exhaust back towards the center to keep its heat, but also reduce any delays in pressure oscillations, maintaining its degree of efficiency and its degree of continued. Looks like Phaser says you should shut up and listen instead of trying to interject and interrupt. With a comment, most likely. Phaser, come on. After the crash out that's going to happen in third, which that used to be for a separation of carbon, meaning hydrocarbon or carbon. Phaser, come on. That I would use to make that occur, okay? As a result, now it's just more for capturing an increased degree of volume, meaning density of the pressure. As a result of that, I gained a pretty decently significant amount of captured energy. See, the second stage is going to have that route back in, so I increase the pressure even further and the reactivity even further, because I don't need as much air after that starts to allow for that increased pressure and density to continue to happen. It's a recirculation design, but it goes into the exhaust. And so there's a pressure here that's happening, and there's a pressure here that's not happening. Well, that means I can put pressure there. That increases pressure. Since you didn't know that, now you know. Exhaust manifold that allows me to shove in the exhaust's, air into areas where it's not coming out, which improves the efficiency of captured turbine style energy, work energy. So apparently you don't know that, but I do, so there's that. Anyways, that improves the efficiency. It also means that it crashes out with higher degrees because they're oscillations, but that means there's already a crashed out and there's not a crash out turning into a crash out. Well, this one's trying to turn into a crash out, but it'll mix and increase its thermal efficiency. In so doing, it makes it more efficient to rip and push in electrons respectively, because there's the right amount from the exhaust, and now this one's needing or trying to be turned into having more. Instead of needing more, it's trying to be turned into having more. And this one, well, effectively is a version of that too, from the exhaust that's coming from the combustion cycle. So it's like it already has a good amount, but there's still meat on the table because not everything perfectly combusts. Well, now we're going to shove more in, and now there's already one that already had everything evened out. And so it'll improve its thermal efficiency because that'll improve its heat because electrons will move, and as a result, you gain heat. If you don't know that, well, now you know. Now, that goes off as it goes from inside, center, to the out approach. It goes back towards the rear. Another version, but instead this one's a bunch of stators that are attached to the blades that just use static charge differences that dump and take out the electrons to take them and work energy is... Can you shut up over there? Can you fucking like, I'm not hearing a voice, by the way, but just so you know, I'm just hearing some fucking comments in my head as they're trying to fucking say that I know what you're gonna say and shit. And they're stupid. I already talked about this in my design anyways, while I was in my apartment, which I've had hackers for a really long time, so my guess is they're fucking one of those that are listening in right now, making comments. Anyways, there are a bunch of stators on the blades. They use the static and then connected ground. It makes an electron flow. Electrons get pushed into the middle in the exhaust that allows for that to occur more easily because it basically builds up like a charge capacitance slash battery that makes it easier to dump them in. And I still have to add more in, but I have a battery. And then I have an alternator, which is the axle thing too, which also happens to have the counter-rotating blades. So magnets and some coils will do just fine making an alternator. So if you don't know that, now you know. Now, then you get further and further and further along with that because it's like, well, that exhaust then gets sent towards the center again, and then it goes outside. Well, towards the center is really more of a trying to take a rotating pressure wave and then sending that into one single solitary continuous pressure thrust that goes into a series of turbine fan blades, which are then going to send it to the axle that's connected to the axle and hub axle respectively, which then goes off into a scoop design as it goes from center out, making a vacuum and then a very high pressure constant thrust, which continuously turns that and captures some of its energy and then turns it into, at the scoop, a one single off to the side exit. And so it goes from really high pressure, and it's got to lose a little bit of heat during that. And it's going to. That's why it goes from a larger diameter to a smaller diameter, and then eventually the smallest diameter off to the side, which is then still got a decent amount of pressure and flow. And so that turned into a angled, corkscrewed kind of style blade that has a shroud around it that has a vacuum it builds up in the center and on the sides, and a moving forward and rearwards sliding axle point for the next counter-rotating blades that also happen to produce their own version of a vacuum behind them. And what it does is it produces a vacuum on one side, and then as they curve inwards with the stators off the vacuum blades, it produces a skip, produces a vacuum, increases torque, still improves its actual flow characteristics and its torque value and capture of energy. By the time it goes to the rear blades, which is only two blades, okay, it then goes from a center out again, and it diffuses off the tips and the stators, with a few holes and a few curves to remove wingtip vortices, and then turns that into a version of diffusal and a constant flow and a reduction of pressure, but then the heat is really taken out and pressure is very taken out. And so then it turns into a much larger, lower 22 kilohertz, but then it's like not totally, actually it's kind of like a jumbled mess of frequencies. So then I turn that into a tube that goes into reeds that then is a basically a version of capturing and then destructive and constructive interference to a 22 kilohertz only signal that I'm looking for, which is a very low signal, or not kilohertz, hertz, very low volume. Everything was supposed to try and come out at 22 hertz, and then it's like I want to make it even more consistent, and then it comes out as a very low, very deep drone sine wave, which are just reeds that vibrate and then have the right chambers in them that then allow for the capture and constructive and destructive interference of the pressure waves as they combine out to the tailpipe, which makes it very high flow rate, and it makes a significant reduction, get out of here, drop is what they were going to say, of total volume and energy, because it takes energy to move the reeds, and they have to vibrate. They have to have the right geometric shape, the right patterning, and the right sound chamber that combines them at the end, which means they have to be floating inside of a chamber that allows that to move and do its job, which it does, and it has that, and that's fine. Comes out as one continuous amount of air, but it also makes a very, very low pressure sound, which is very well tolerated, and you can hear it for a very long, significant distance. That makes it much easier for you in every way to understand and know that a vehicle is coming. And nobody complains as much. And it's a very cool sound anyways. So, big bassy notes are generally speaking that are very boomy and large and huge soundstage, usually speaking, wanted. So, instead of a high-pitched whine turbine turbo, it goes into a much lower, big, huge volume bass note. So that's a good thing. As a result, that's why I made it for semi-trucks. It's an enormously efficient, extremely cheap, and very powerful engine. Like, seriously, it's stamping some stuff together and then casting it for some other things, and then layering some ceramic, which truthfully is like something that we have massive behemoth machines that do literally exactly that are cheap for what it's worth. So it's actually really cheap to produce this engine. And it's the right ceramics. Yeah, well, the ceramics aren't that big of a deal. We have ceramics that we already know work very well for this, that are fairly cheap and already available on the market. So, effectively, why wouldn't we do it, is what you're saying. That's why I designed it my way, because that's exactly what I want them to say if I were to go to investors. That's exactly right. Person in the comments, why wouldn't we do this? That's literally it. And the turbine's a very cool design. Yeah, it does its best to combine, equal length tube stators, essentially. That way they all combine out. It all just takes the right amount of tube length, so they all deposit at the same time, as one continuous flow from the top and the bottom. The multiple stators in the rear are just a version of the electron flow, which will produce some degree of exothermics, but it's really just capturing energy for what it's worth, which is fine. That's all I want, because I already have 2 pressurized systems. And for the, if you heard my water, engine, my electrical internal combustion steam engine, which was the previous thing I recorded, literally not even that long ago, then you also should know that it's a version of that. It's 100%, then a slightly degreed higher 105%, and then about 80%, which is a large amount of incredible efficiency and power, especially since the turbine setup in the rear and then the last final turbine setup can all add to work energy, which by the way, that's not work energy for the final turbine. I just turned that into electrical energy to help with the actual engine, so that allows for an improved efficiency, especially with the higher degrees of compression that it starts off with, and then especially as it starts moving faster. So the reason why I designed it like that was because semi-trucks could use hydrogen in a capacity that actually makes fucking actual sense, which is the whole point. You know what I mean? It was like, hydrogen is stupid. You would run every which way. It's fuel cell. Well, this now actually makes a fuel cell level of efficiency for the given amount of hydrogen used. And now I don't have any carbon output at all. And I actually give you more torque than an electric motor will provide you, with greater degrees of horsepower too. And so I have longer duration than what a fuel cell can give you, along with more power. And now the Interd turbines, which is like literally a super hyper efficient turbine, which is the reason why it's so enormously better than other older, shittier 40%er style turbines, because it built itself to make sure to recycle the energy and recapture the energy into work energy, instead of it just blew it out, which it still has a very high degree of flow. And the improved degree of compression from the start, and then after it improves its efficiency even greater thanks to the increased ram air capacity that I talked about in the previous recording. So it was a way for me to get around shitty designs. But the problem is, it's like, well, this is 3,000 horsepower and 15,000 foot-pounds of torque for hydrogen fuel use. And it was like, yeah, God, that's a lot. Oh, fuck. Like, just basic, capture of thermal dynamics and fuel use. You know what I mean? It was like, right, and the pressures and then rotation and then actual, all the rest of it. It's like, oh, yeah, no, that's about right, especially since I'm not running at high RPM. I don't do anything more than a 7,777 RPM. That's the only amount of RPM you get. You are not allowed to go above that, although it's rated to do well over 1 million RPM for its balancing and more, but that's a lot of fuel use, and I don't want to. So it was like, yeah. Also, it's technically speaking acting like a rotating engine, like an actual rotating engine. So it's kind of like a piston engine that's just rotating, and like a turbine, and like a jet engine, because if I have that exhaust come out the right way, it's a jet engine exhaust. So which produces a very significant amount of thrust, especially if I add all three of those packs instead of only trying to capture it for torque and energy efficiency. Then it turns into thrust, which is equaling to header exhausts into one singular bell end area as the exhaust with the correct stators and delays. Then I get, with the improved thermal efficiency of the vacuum insulation and the ceramic insulation, then I improve its thermal output efficiency for the given air intake volume and outright exhaust, which still has an axle, which is why the prop design, like large props in the front and then props in the rear, and then the exhaust comes out quite quick too, to then be added into already fairly fast, fairly high compression air, and then that gets sent through its own version of a rotating prop that's smaller and bites harder, so that way it then will go into its own version of a faster flow rate. And then I was like, well, those props can be hollow, and I can just add hydrogen to that. As it goes from the center outwards, then it's its own version of hydrogen wicking and pressurization, and with extra air and heat and compression, that then allows for its own version of a full end massive amount of hot, compressed, high velocity air that goes into its own extendable bell end housing that is using a version of a aerospike that's on the bell end with stators that then has pressure in it that slowly changes based upon the atmospheric conditions outside and inside, trying to match for that 1 atmosphere of continual thrust passively, and it extends the bell housing and widens it as it moves, which is really, really good. It was supposed to be for very high altitude and low altitude prop engines, jet engine, prop engine, hybrids with a turbine. Very different approach, where the center axle of the prop at the front is actually going to extend outwards to get that plug of air to then be sucked in and then curve that offset as it will bifurcate and then kind of curve inwards to improve its efficiency to the props behind, while that hollow air goes into the center for my ram air for the engine turbine, which of course improves outright efficiency the faster you go, because it's a much larger prop too. More efficiencies, lots of efficiencies at very high altitudes. Look at the efficiencies. It's using hydrogen. Look at this bad boy. Dong. Holds so many hydrogens and airs and ionics, because I got the wind, and it was like, yeah, there's nothing saying I can't make because it's rotating enough. Like, just because it's rotating doesn't mean I can't stop it from producing enough electricity, especially at those higher RPMs, to then make ionic and then plasma for the hydrogen in the rear blades, and then ionic from the intake area props that then allow for it to crash into the bell end and then produce from a nozzle perspective, kind of like give you extra oomph to the whole design. Lots of increased speed, hyper velocity. Yes, hyper velocity. High Mach, hyper Mach. Probably 15, most likely at very high altitude, because of the increased degree of surface area to compression ratio. And ultimately, Bernoulli's principle still remains fairly consistent from what I understand, especially with the extra heat that's there being generated and the efficiencies of moving parts therein gaining. I improve its design's characteristics for those hypervelocity flows quite significantly, and the improvement of thrust is rather pronounced. which gives you a spaceplane design, which is the whole reason why I also made it for that. Because I was like, well, for what it's worth, I only use the medium size for like one of those larger engines. The bigger engines meant for like actual fucking huge, Connex, big boats, big huge boats, cargo boats, ships, that thing. Like big, big, big boys. Humongous. Because they're really, really good at improving the design's efficiency of the boat. Because, well, big old prop now becomes big old boat prop, while maintaining just hydrogen and some carbon if you want it. Like, you don't really need the carbon, which improves your fuel efficiency. Because you can survive off of hydrogen for that long because, well, you're a ginormous fucking boat and you have a huge storage tank that can absolutely be insulated and remain with liquid hydrogen for a much longer degree of time, while allowing for the batteries to do their job, because of course you still have this thing called surface area, which means you also have this thing called the sun, solar, which improves efficiency, especially since sails, which normally wouldn't really help you, well, they can help you on a slow speed start, and then that'll give you a greater degree of efficiency as your engine warms up off the line, and then you can remove those and take them down, which are their own version of flexible solar sails. Pretty good as you're waiting around doing fuck all nothing anyways most of the time. Just sitting around in the dock trying to get everything moved. So not going to get in the way of people being able to remove anything for what it's worth, because you can take them down. So there's that. So, every time I look at this, I'm like, this is stupid. Look at the stupid boat. Look at the fucking stupid boat. Who's designing the boat? These boats are stupid. This ship is dumb. Look at this ship. It's so inefficient. Look at the hull on this ship. Where's my hydrofoils? Where the fuck are my hydrofoils? I want my Where the fuck did that go? This is stupid. You know what I mean? Yeah. But it's like, not for them, for whatever reason. And for what it's worth, I guess it's good enough. But for me, it was like, well, higher degrees of efficiency for the mass gained and the degree of lift that we need to achieve with a reduction in overall frictional components, thanks to hydrofoils designs. We just need it to be strong enough to support itself, which means multiple hydrofoils instead of one or two. And if our United States America military can design a hydrofoil for a ginormous destroyer or fucking goddamn ship, I'm pretty sure we can do it for cargoes. Which definitely means it's doable, which definitely says to me, like, that's coolant also, for cooling, instead of needing, like, a radiator, like, those are a bunch of hydrofoils, which is coolant flow, and then I can still just pump, a ridiculous amount of, like, water through one side, and scoop it in, and spray it out another, like a jet ski, which improves, depending on its boundary characteristics here, its efficiency as well. Instead of a prop, it's like, well, I need higher degrees of flow. So it's like, right, and a prop design will have cavitation. And sometimes I'll use cavitation to improve its boundary layer characteristics and the flow directionality and outright performance therein of a prop. But it comes every time with increased complexity, and it's usually very good at certain speeds or up to certain speeds, and then after that it's kind of stupid and it sucks as a result. You know what I mean? It's like, right, it's really good up to this, and then it's just like anything else, and it doesn't work as well. So a way around that with jet skis is, well, I have multiple pickups with the right filter, so that way no fish and shit are gonna get in there. That way it goes out. I suck in that. That's multiple, you know, jets that then combine into one jet, which is a bigger version of that jet that just helps that effectively happen with less loss of the energy of combining multiples into one, but also speeds it up. And then I improve the efficiency of the given design of a jet ski in jet because it's using multiple small to one larger, which gives you an increase of total volume, and volumetric efficiency is now improved. It's kind of like the old style jet engines. You take the certain, size inlet, and then it goes out to the outsides, and the center is still relatively untouched. Then those goes into small styles. Can you shut up over there? I'm talking. Small style inlets, small style chambers. They compress. They add in some fuel, and then it goes and it spins the outside of the turbine blades and then combines with the fresh air that's in the center, and then blows out the rear end that gives you your thrust in a jet engine. Well, it's kind of a version like that. Take a bunch of smalls to a big large, and then that improves its efficiency because I can still suck in for the large. See what I'm saying? Which I didn't say that, but I should have said that actually now that I think about it. But I think that I figured that would be implied, but right, it's not. So like some people don't know about that, right? So it's like it would be like the big one and then a bunch of small ones, and so it improves efficiency and you give outright velocity performance for what it's worth, especially for rolling one of these big boy hyper efficient packs, which are for the donut side. Like, because the hub is rather significant. It's going to be pretty big. It's basically like, a small beach ball. And then you have the big beach ball, like a big boy beach ball. That's for the intake area. And then you have the compressor and all the rest of it. You're going to burn a lot of hydrogen, but then it's going to be efficient enough with the right amount of packs and the right amount of turbine after effects, meaning, to improve its torque and capture of energy, because you already don't care about the weight. To a point, it's going to be less weight than those huge, massive engines. It's already going to be a lot of weight, but it's like way less weight than that. And as a result of also being more powerful and more efficient, you basically gain that profit, which is a good thing. You're looking for that. Especially with a hydrofoil package, it's like, look, I can get to and from and and it's like, yeah, great, yay. I know. For me, it turns into like, yeah, great, yay, sure, but also, it's like you do and you don't. It's one of those like, yeah, no, so, the docks are slow. I can get from there to there and I burn basically way less fuel for what it's worth, and you're more efficient, so you get that profit, but then you're languishing around and you're not going to get another amount of, profit anytime soon. So, there's that part, which is why it's like, well, if they could just pick it off while we're moving and refuel us, would that be a thing? It's like, oh, yeah, no, sure. Right, yeah, no, the whole in the water, dumpage and refueling. Get that style going. And look at my port. It's a fucking water port. It's a huge 10-mile long port out in the middle of the Pacific Ocean and Atlantic. Let me just aim perfectly and just go through that, and they'll just fucking, with their arms, take out the Connex boxes. Oh, shit. It would work, but it's also like that would be highly dangerous, and I don't think people would do it. So no, yeah, but it's an efficiency gain that's not really there because you're still going to be burning that fuel. At least when you stop, you're not burning fuel. You know what I mean? For them, it's like it's profit. It's like, oh, I can burn the fuel. You know what I mean? But I'm gonna have my next one loaded on by the time I leave, or I swing back around and get it loaded on, and then I'll fucking get somewhere else, and and it makes it faster. So you get more profit more often for the fuel burned, especially with the efficiency that's there. But it's like, I don't know. For me, it turns into like, that's a lot. Might as well just freaking do. The do tends to make it work. All right, so I have to go take the laundry and put it into the dryer, since that's a thing. We should now do the next one.